Hello viewers, in today's class we are going to discuss an important problem from absolute value function, right? So in this lecture we'll solve this integral involving the absolute value of sine function. So here we have the integral from 0 to pi and absolute value of sine x over pi dx, right? So let us call this integral as I, and this problem is going to be very beneficial for the beginners, right? And we can also categorize this integral as an elementary integral. So to solve this integral, we are going to use a lot of concepts here. First, we will use the concept of absolute value function, then the sign convention of trigonometric functions in the different quadrants. So let us make use of the method of substitution. So here we have a mod of sine x over pi, right? So let us take u is equal to x over pi. So here we are introducing this variable u as u is equal to x over pi, so that x is equal to u times pi. So let us differentiate x with respect to u. So dx over du is equal to 1 times pi, because the derivative of u with respect to u is 1. So dx can now be written as pi times du. Okay, so now see here the limits of integration vary from 0 to pi. So when x is 0, then the value of u can be obtained from this relation. So we have u is equal to 0 over pi, that is equal to 0. And the upper limit is pi, so x is equal to pi. So u is pi over pi, right? Here we'll take x is equal to pi. So this is 1. Pi and pi get cancelled. So when x vary from 0 to pi, then u goes from 0 to 1. So now let us rewrite this integral in terms of u. So we have the limits now 0 to 1, right? And we have mod of sine u, and here for dx we can now write pi du. Taking this pi outside the integral, being a constant, so we have 0 to 1 mod of sine u and du, right? Now to move further, here we have to make use of an important concept in trigonometry, and from the concept of real numbers, let us see how we can simplify this integral. So let us first see the limits, right? See here u vary from 0 to 1, and u is 0, and the lower limit is 0, the upper limit is 1, and 0 and 1 are both real numbers. So this is an important concept here, right? So the limits are real numbers, and here we have sine of u, right? And we know that when we define trigonometric functions, then we define the six trigonometric functions in terms of real numbers, right? So whenever we talk of say sine x, then it implies that this x is a real number, right? So here this u is a real number, right? So this is one thing. The other thing is that if we take the quadrants, this is the first quadrant, this is second, this is third, and this is fourth, right? And since here we have only the sine function, so we will restrict ourselves to the sign convention of sine function only. So in the first quadrant, sine function is positive, in second also it is positive, and in the third and fourth it is negative, right? And now let us move to the limits. Now see, here u lies between 0 and 1. So here 1 is actually 1 radians, right? And we know that 1 radian can be converted into degrees, or 1 radian is equivalent to around 57.29 degrees. So it implies that the value of u, that is this angle, it varies from 0 degrees to 57.29 degrees. And when we move from 0 to 57.29 degrees, then it implies that we are in the first quadrant, right? And in the first quadrant, the sine function is positive. So we can now write mod of sine u as simply positive sine u, right? Where u, it belongs to the first quadrant, that is from 0 to pi by 2, right? So this is pi, this is 3 pi by 2, and here we have 2 pi. So now this integral I can be written as pi. We have 0 to 1. Mod of sine u can be written as positive sine u, and here we have du. Now the integral of sine is negative of cos, so we have cos u, and the limits of integration are from 0 to 1, right? So taking this negative sign outside, and we have cos of u, limits are from 0 to 1, so this is pi, and here we can substitute the limits and we'll take the difference, so cos of 1 minus cos of 0, right? So this is pi, taking negative sign, multiplying these two numbers by this negative sign, we have cos of 0 minus cos of 1, so this is pi 1 minus cos of 1, right? So the value of this integral I can be taken as pi times 1 minus cos of 1, right? We can also rewrite, or we can also express this value in another form by utilizing a trigonometric identity, that is 2 sine square theta over 2 is given by 1 minus cos of theta, right? So now replacing this theta by 1 radian, we can now write 2 sine square half is equal to 1 minus cos of 1, right? So taking theta is equal to 1, we have 2 sine square half is equal to 1 minus cos 1. So now this I can also be written as pi times we have 2 sine square half, right? That is 2 pi sine square half. So the value of this integral can either be written like this or by this expression.